Hi everyone, in this video we're going to be talking about graphing cosecant and secant. We are going to just review that the cosecant is the reciprocal of sine and that secant is the reciprocal of cosine. What we're going to do, and the only thing we're really thinking about here, is flipping over the y values for sine and cosine, so flipping over the outputs from those sine and cosine graphs. So if we think of the graph of the sine function, it looks like this. And if we think of the reciprocals of these, well, we're going to have to think about these 5 points and flip those over to think about when we start thinking about the cosecant theta. I'm going to make that in a different color. Let's make that in orange. Okay, so if I take 0 and I flip it over, I get the reciprocal. I get something over 0 that's undefined. The same thing is going to happen here at point 3 and here at the 5th point. Whenever the output is 0, if I try to take the reciprocal, it's undefined. So I'm going to get asymptotes at those 3 values. Now, what happens when I flip 1 over? I get 1. What happens when I flip over -1? I get -1. Now we've got to think a little bit more about what happens here. So if this is pi over 2, I've got to think about what happens at pi over 4, and I've got to think about maybe what happens at 3 pi over 4, or easier at pi over 6. Here at pi over 6, the sine would be 1/2. If I flip that over, that's 2. Here, if I go to 60 degrees, the sine at 60 degrees is also 1/2, but if I flip that over, then that's +2. And so the graph of the cosecant of x starts to almost look like a flip of, not a complete flip, but if you use your imagination a little bit of a reflection of those, of the top of that sine curve. It's kind of in the shape of a parabola here between 0 and pi. And actually this should say this, I'm sorry. This should say y equals the cosecant of x. Okay, so now over here, if I look at these values, which would be, let's see, past pi, so that would be 5 pi over 6. The value of the sine is -1/2, and if I flip that over, I get -2. And here, let's see, pi over 6, so that would be 11 pi over 6. I would get 1/2, but I flip that over and I get -2. And so the second part of the cosecant curve looks like this. So cosecant has 3 vertical asymptotes where sine is 0. And then it has that U-shaped look where the high points of sine are the low or high points of the cosecant curve. Okay, now if we talk about the cosine curve, what we see is that cosine starts high, goes through the axis, and then goes low, and then ends high. So there's the graph of cosine. Now if we are going to graph the secant function, y equals secant x, which is the reciprocal of cosine, we're going to look at where the y values are. Put our vertical asymptotes there. So here with cosecant, or excuse me, with secant, there are vertical asymptotes here where at points 2 and 4. All right, now we have to think about the reciprocal functions. Well, again, the high point of cosine here is going to be the low point of secant, and it's going to follow that same sort of pattern. Because sine and cosine kind of look alike, and we've been talking about this, the graphs of cosecant and secant are also going to look alike. When I take the reciprocal of these values, this is in fact what secant starts to look like. So it has a very similar look to the cosecant curve. All right. Basics of cosecant and secant. The highs of the sine and cosine curve, as we can see in these pictures up here that I just graphed, would become the lows of the secant and cosecant curve. So we'll do those points in red, right? That high point of sine becomes the low point of cosecant, and the low point here of sine becomes the high point of cosecant. And similarly, the high point here in red of the sine curve becomes the low point of cosecant. The low point of the cosine curves become the high point of cosecant, and then here the high point of the cosine becomes the low point of the secant curve. Okay, the zeros are undefined, and we represent something being the reciprocal of we represent something that's undefined as having an asymptote. So to graph the cosecant and secant functions, we're going to identify the amplitude, the period, any kind of phase shift that takes place for the sine curve. So we're going to really start with graphing the sine curve or the cosine curve, and then we're going to graph from that sketch. We're going to fill in the sketch for the cosecant and the secant, and I will do that in the next video, which is example 1.